This video will focus on Chapter 7, Section 1, where we'll focus on the concept of sampling error. We've already discussed how we use sample statistics to estimate population parameters. Remember that we use the sample mean, that's x bar, as an estimate of the population mean, mu. Our goal when collecting a random sample is to get a representative group from the population so that x bar accurately represents mu, or whatever sample statistic we're calculating accurately represents the population parameter of interest. Unfortunately, there are problems associated with this. Different samples provide different estimates of the population parameter. We don't actually know if the sample that we're collecting accurately represents the population of interest. Because we have a sample, those results that we get have variability, meaning that they don't necessarily accurately represent the true population value of interest. Because of that, sampling error exists. So what is sampling error? Well, it's really just the difference between the statistic that we're calculating and the associated parameter we're interested in. So if we're interested in studying the mean, our sampling error for the mean would be the sample mean, x bar, minus the population mean of mu. We always have sampling error because this x bar is calculated from a sample of the data, not the entire population. So here's an example. Suppose the average temperature of a human being is 98.6 degrees Fahrenheit. We've taken a sample of 5 temperatures, and this sample yields an average of 99.2 degrees. Well, that's not 98.6. The sampling error then is the difference between the sample mean of 99.2 and the population mean of 98.6. So we calculate this as 99.2 minus 98.6, and we get 0.6 degrees Fahrenheit. We put the sample mean first when we're doing the subtract because we want to know if it's too high, if our error is positive, or if it's too low, our error would be negative. So we put the sample mean first, and if we get a positive value, that means we've erred on the positive side. If we get a negative, that means we've drawn a sample that comes up on average lower than the population mean. We'll get a negative sign here. Different samples will likely yield different sampling errors. Because each sample we get, we will probably get a mean that's different than the true population mean, which means each of those samples will give us a different sampling error. The sampling error may be positive or negative. So if x bar is greater than mu, we will get a positive sampling error. If x bar is less than mu, we will get a negative sampling error. The size of this error in general depends on the sample itself and the sample size. In general, a larger sample means a smaller sampling error. But it's possible that we draw a larger sample and that sample is not representative of the population. If that's the case, the sampling error will get larger. So I use the example of income here. If we were trying to measure the average income in the United States, and we collected incomes from about 200 households in Monmouth, we would get an income that's probably slightly less than the national average. If we were to increase our sample size by 1, so instead of the 200 households in Monmouth that we talked to those 200 households, plus we add in Bill Gates. Our sampling error doesn't necessarily get smaller. Bill Gates' income is so large that if we add him into the 200 households that we've already calculated here in Monmouth, that might pull our mean up so high that our sampling error gets significantly larger. So sampling error exists. Now, we've made this look like we will always know what the sampling error is. But remember, we don't usually know that true population parameter, so we won't actually know what the sampling error is. We need to understand that this concept exists so that we realize whatever values we're getting for those sample statistics are likely wrong. We don't know how wrong they are, but they're likely wrong. However, they're our best guess based on the sample of data that we've collected. This points again to why it's so important to get a sample from the population that is fairly representative of the population. If we do so, our sampling error can be minimized.